In this section, we are going to talk about the reactions of alcohols. What kind of reactions do alcohols normally undergo? Alcohols normally do not undergo substitution reactions unless it is activated. Let's consider this simple reaction. You have methanol reacting with Br minus to give alkyl halide. This reaction as such is not going to undergo. The reason for that is OH is strongly basic and therefore it cannot be displaced. If this reaction is not possible, how can we do a substitution reaction with an alcohol? If you ever want to do a substitution reaction with alcohol, it is still possible, but you needed to activate the alcohol first. What do you mean by activation? Activation is converting a bad leaving group into a good leaving group. You have, we talked about the OH in the last slide. OH is a very bad leaving group, right? If you want to convert this OH, if you convert this OH into a good leaving group, then the substitution reaction, nucleophilic substitution reaction of alcohols can happen. Okay, so what happens here is HBr in the presence of an acid, the oxygen with its lone pair of electrons is going to go grab this hydrogen, and OH minus is now converted into water, which is actually going to be a good leaving group. And now your Br minus will go and attack this carbon, doing an SN2 reaction, and thrust this leaving group out. And this reaction as such is going to be slow, and therefore you need to have heat in order to make the reaction to go fast. Okay, remember, you need to use only weakly basic nucleophile. If you're going to use a strongly basic nucleophile, then the alcohol is actually going to be deprotonated. So the product would be CH3O minus, which is going to be a strong base, and that is not going to undergo any nucleophilic substitution. Let's compare the reactivity of the different alcohols. In general, the primary and the secondary alcohols, they're not as reactive as the tertiary alcohols, and therefore they require heat. So here is a primary alcohol, and this is a secondary alcohol. This is a tertiary alcohol. So for primary and as well as secondary, you need to have huge amount of heat for the reaction to happen. Whereas for tertiary, you do not need any amount of heat because it's already reactive. Okay, now let's identify what type of nucleophilic substitution reaction the alcohols are going to undergo. In general, secondary and the tertiary alcohols do undergo via SN1 mechanism. Okay, let's take a simple tertiary alcohol. Here is a simple tertiary alcohol, and we want to convert this into an alkyl halide by reacting it with HBr. So when this reaction happens, what's the first step? The first step is to activate the alcohol, where this strongly basic OH group needs to be converted into a good leaving group. So where the electrons from the oxygen is going to go grab this hydrogen and the Br is going to leave, right? So let's draw the product. Now here is our product. Right? Now that has been converted into a good leaving group, what's the first step in an SN1 mechanism? Yes, the leaving group is going to leave, right? And it's going to form the carbocation. So let's also draw the structure of the carbocation that's obtained. So this is your carbocation, and this is going to be your leaving group. Okay, now once it forms the carbocation, it has two possibilities. Now it can react with Br minus to form the substitution product. Remember, this Br minus is going to go attack this carbon, and it's going to form the substitution product. Or, remember, H2O has been liberated, and this H2O can actually go grab this hydrogen and then thrust that bond here to form the double bond. That's going to result in elimination product. Let me draw the elimination product. It's going to look like this. You get majority of the product that's formed is here as substitution, although you can expect some amount of the elimination product. But this elimination product is actually going to undergo subsequent electrophilic addition reaction with HBr. Remember, this is an alkene, and an alkene can undergo electrophilic addition reaction with HBr, where the hydrogen is going to go to the carbon, which has the most number of hydrogens, and the Br is going to go to the other carbon, in which case this is going to be your only product that's obtained. So on the whole, we can tell the secondary and as well as the tertiary alcohols, they do undergo substitution reaction provided it is activated. Also remember that in an SN1 reaction, there is a possibility for carbocation rearrangements. Here is one such example where there is rearrangements happening, carbocation rearrangements happening. Here is a secondary alcohol, okay, which is being reacted with HBr to undergo an SN1 reaction. Now, what's the first step? The first step is activation of the alcohol, right? So where the electrons from the oxygen is going to go abstract this hydrogen, the Br is going to leave. Okay, let me write down the leaving. Here is your leaving group. And now that it has been converted into a good leaving group, it can now form carbocation, right? Let's write down the structure for the carbocation. Here is my carbocation. Now, you need to find out whether this carbocation can be changed into another carbocation through some kind of rearrangement. We have talked about 1-to-methyl shift and 1-to-hydride shift. Is there an hydride ion that's available that can shift to the second position? Yes, there is definitely an hydride ion that's available, right? So for explaining purpose, I'm going to put this hydride ion here. So this hydride ion can actually shift to the neighboring position, which is the second position, and the carbocation is actually going to shift to the first position. So let's see. This was once a secondary carbocation, but once the 1-to-hydride shift happens, it's now converted into a tertiary carbocation. And we already know that the tertiary carbocation is the most stable one, right? So this is the most stable one. This is your tertiary carbocation. It is the most stable one. And therefore, you get this as your major product when your Br minus will go and attack it. So when the Br minus will go and attack this carbocation, you will be getting this as your major product. And this would be your minor product. Okay, this is your major, and that's your minor. Major product. Okay, so always watch out for carbocation rearrangements when you in an SN1 reaction. Now, primary alcohols, they normally undergo only SN2 reactions, and we already know what's the reason for it. Generally, primary alkyl halides, they do undergo only SN2 reaction because of the steric hindrance. So in the same way, primary alcohols can only undergo SN2 reaction, but here again, it needs to be converted into a good leaving group. The OH needs to be converted into a good leaving group. Now let's take an example here. We have ethanol. We already know that this is a primary alcohol. If you want to react it with HBr, the first step would be conversion of this strongly basic group into a good leaving group, okay, where the electrons from the oxygen is going to go grab this hydrogen and the Br is going to leave. And now you have your good alcohol, your protonated alcohol, which is actually going to have a good leaving group. Now your Br minus is going to go do the backside attack. The Br minus will come in a direction that's opposite to that of the leaving group, and the leaving group is going to leave, which is your basic SN2 examples that we have seen. We have only been using HBr. Okay, when you use HCl, you need to use a catalyst, zinc chloride as a catalyst. And you also need to heat the reaction for it to go fast. What's the reason behind using zinc chloride? Remember, Cl- is the poorest nucleophile of all the halide ions. And therefore, you have to use a catalyst. This catalyst, zinc chloride, is going to increase the rate of the reaction by creating a better leaving group than water. Now let's look into the mechanism for the reaction. The first case, the alcohol is actually going to react with zinc chloride. So the lone pairs of electrons on oxygen is going to go attack zinc, and one of the Cls is going to leave. Okay, thereby it's going to get converted into a good leaving group. And this oxygen is going to have a positive charge, and this is going to be your leaving group. Now remember, we are talking about the SN2 reaction, and the Cl minus, since this is a primary alcohol, we are talking about the SN2 reaction. The Cl minus will now do a backside attack on this carbon, and since this is going to be a good leaving group, it's going to leave. Okay, and then you will have your final compound, which is your alcohol, which is your alkyl halide. Now, why do you want to convert all the alcohols into alkyl halides? Remember, alcohols are readily available, but they are very unreactive. Alcohols are unreactive, whereas alkyl halides, they are less available, but they are very reactive. So if you want to synthesize any compounds, the best route is to convert the alcohols into alkyl halides and then convert it into different compounds of your choice.